Hello everyone, I am Anushka Soni from Udaipur City and Sarpadampat Singhania University. My team including our mentor Dr. Kuldeep Chaurase sir and teammates Aditiram, Uttej, Uttam and Ayush. We are working on deep learning based water feature mapping using satellite images. The main purpose of our project is extraction of water features. As we all know, there is no life without water. The purpose is to provide service of water to urban consumers for irrigation purpose, forecast floods and droughts. The problem statement is to extract linear and non-linear water features from the Sentinel-2 satellite images dataset. In this project, a unique deep learning architecture is proposed to extract various Earth objects from the medium resolution approaches imagery using deep learning approach. The models we are working on are UNIT and encoder decoder. So let's take a look over the dataset and each model.
Hello everyone, I am Ayush. The data we are using is generated through Sentinel-2 satellite. Height and width of the data utilized is 3455 cross 5063 pixels and has a resolution of 10 meter. The study area is situated in India, Delhi NCR. The images have three bands, red, green and visible and near infrared. For augmentation, we are taking transpose of each image and its respective ground truth. We have a total of 2160 images, out of which 1710 images we are using for training, 234 images for validation and 216 images for testing. Programming platform used is Python. For data reading we are using GTL library and for augmentation we are using NumPy library.
Coming to methodology, we took reference of two models. One is unit and another one is encoder-decoder model. The unit consists of convolutional layers followed by max pooling in encoding layers and copy and crop from previous layers in decoding layers. In unit, we made modifications such as zero padding and removing cropping of images from previous layers so that the dimensions remain same. We also included batch normalization to speed up the convergence. We also removed few layers in order to make the model more suitable for our application. The other model, encoder-decoder model, consists of convolutional layers followed by max pooling, dropout and batch normalization in encoding layers and upsampling, dropout and batch normalization in decoding layers. In this model, we made modifications such as using min pooling instead of max pooling and removing few layers in order to make the model more suitable for our application.
Hi, I'm Aditya Ram. So continuing on what Uttej said, it was evaluated that we needed less layers because there were only two classes to foresee, which is waterways and non-waterways. So we removed one layer from our encoder-decoder model. We also used ReLU activation on every layer except the last one, and we used sigmoid activation function for the last layer, so we got a value either 0 indicating non-waterways and 1 indicating waterways. We then trained our encoder-decoder model and the UNIT model for 200 epochs using the training and validation set. We then tested both the models using the testing set, and these were the outputs. You can see the original images, the ground truth images and the predicted output. The accuracy and loss graphs for the training and validation were as shown. So to summarize the entire process of our project so far, we read the .tiff images and the ground truths from the data set into arrays. Then we augmented the data and we divided the data into three sets, the training, testing and validation set. We then prepared our encoder-decoder model and the UNIT model and trained both of them for 200 epochs. Then the test images were processed and the outputs were predicted. Next we move on to the results section.
Hello everyone, I'm Uttam Gandhi. So coming to the result section, in the initial stage we have tried with the UNIT model but we haven't got the desired result. So we had implemented the convolutional encoder-decoder model and we were able to map the waterways more accurately. Coming to the various performance evaluation metrics, we have secured an accuracy of 99.96% compared to the accuracy of 99.93 in the UNIT model and a precision score of 88.11. Recall of 90.75 and an F1 score of 89.41. Urban water mapping is essential for smart city and other urbanization developments. We created a convolutional neural network that predicts the waterways from low spatial goal pictures of the Sentinel-2 satellite. The model can separate low-level features identified with water with a precision of 99.96%. In the future, this model can be used to extract other features which include agricultural areas, urban establishments, roadways, and